and welcome to another episode of Engineer to Engineer. Today on Engineer to Engineer, you'll be hearing from our Product Manager Ryan Middlebrook as he discusses the differences and benefits of two of our core rolling element linear guides. He'll also briefly explain some various applications that each linear guide could be useful for. Let's go join Ryan.
The first is a round rail linear bearing assembly. This product's great for low to moderate load requirements, low to moderate accuracy requirements, and it also allows you to move a load over an unsupported gap. It doesn't have to be continuously supported and will tolerate some misalignment as well as deflection. It's typically used in a parallel configuration, meaning that you have to have two rails in parallel with four bearings, two bearings per rail, and it's typically used in a range of different applications for different reasons. 3D packaging or 3D printing, for example, is a frequent user of this technology because it can traverse a clear span, so unsupported area and still support the load. Additionally, packaging, where you might have a sealer opening, closing to seal a plastic bag or some other type of packaging material where you're not able to support the axis, is an ideal application for this type of guide technology. It also has a relatively lower rolling resistance than a square rail product because the end seals on the bearings make minimal contact with the inner race or linear shaft, generating a low level of resistance. The balls in the loaded circuit generate a relatively lower load capability than what you might find in a square rail guide product because it is a point-to-point contact between the ball and the round linear shaft. That brings us to our next technology, which also uses a loaded ball technology, but in a different fashion. On the inner race, you may be able to see here that this product has what we would call a ball conforming groove. This groove matches the diameter of the loaded ball in the bearing in order to maximize the surface contact that the ball has with the inner race. What this facilitates is it allows a maximum transfer of load from the carriage to the inner race. So in effect, it's able to generate a higher load capability per ball because of the higher surface contact with the inner race. So whereas on the round rail product you have a point-to-point contact, this is more indicative of a line-to-line contact and therefore generates a higher load capability. The benefits of this product are that, in addition to the higher load capability, are that it can be used in a single rail configuration. We have a range of different flange styles and additionally carriage styles to accommodate different envelope requirements. The trade-off is that it has to consistently be mounted to a machine metal surface and continuously supported because it cannot tolerate any of the deflection or potential misalignment that a round rail bearing can tolerate. You'll typically see these used in machine tool type applications. They're great for moderate to high load capability or requirements, moderate to high accuracy requirements, and therefore they're used in a range of different applications that kind of require that criteria.
Well, that does it for this episode of Engineer to Engineer. We hope you found this helpful, and if you have any questions about our linear guides or any of our other products, feel free to post it on our social media. That way everyone benefits from seeing your question as well as our answer. You can also reach us directly through engineering@MISUMIUSA.com. If you like this video, hit the thumbs up button and also be sure to subscribe to our channel to stay up to date on all of our new content. In the meantime, check out some of our other videos, our social media, and our new blog, the MISUMI Mech Lab. You can find the links to all of those in the description below. Thanks for joining us, and we'll see you in the next video.